Hi everyone. In this lesson we want to look at how we can solve polynomial equations both graphically and algebraically by factoring. So let's get started here. Suppose that I have this polynomial equation x cubed plus 2x squared equals x plus 2. And you'll remember a couple ways that we can solve this equation. First, let's do it by the intersection method, which means I'd want to start off with graphing each side of this equation. I'll call this y1 and I'll call this y2, and if I graph those and see where they intersect, that will tell me the solution to that equation. So let's go ahead and do that. Let's graph this. I'm going to graph x cubed plus 2x squared. And then at the same time, let's go ahead and graph the x plus 2. I'm going to hit my zoom standard here to get my standard window that goes from minus 10 to 10 in the x direction and minus 10 to 10 in the y direction. And you can see that there are several points of intersection. So this x plus 2, you can see that's the line, and the x cubed plus 2x squared, that's this sort of squiggly curve right here. And I want to know where they're equal, and equal in terms of the graph means where they intersect. Now let's blow this up a little bit. One way to do that is to hit zoom 4, zoom decimal. It gives me some nice trace values and also makes it a little bit more zoomed in. And so it looks like right here that this would be one point of intersection. Let me go ahead and take a screenshot of that. Okay, so we can see that I have a point of intersection right here, and notice it's looking for the x values, right? I want the x's that make it true, and this is x equals -2. And there's this point right here. Here's another point of intersection, and again we want the x value. That's x equals -1. And it looks like there's another point up here. That's going to be x equals +1. Now I can double check those on my calculator. I can actually compute those. I just sort of eyeball them to get these, and for simple exercises typically it'll turn out to be integer values like that. But let's go ahead and calculate number 5 here on the calculator, the intersection. And notice it asks you for a first curve, and it's down here on y1, x cubed plus the 2x squared. Let me hit enter there. In fact, let me scoot it over just a little bit so that when I hit enter, you'll see it puts a little mark there. And then the other one I want to find the intersection of is the line, the x plus 2. And then notice there's 3 points of intersection. That's why it's asking for a guess. It can't read your mind, doesn't know which one you want. So let me arrow down here. Let's get kind of close to this one and hit enter, and sure enough it shows me that the intersection is -1. And I could do that for each one of those, and I'd get -2 for this one, I'd get 1 for this one. Now there's another way that you can do the same thing graphically, and that's with the zero method. With the zero method, what I want to do is get 0 on one side. So the first thing I do on the zero method is I would bring the x plus 2 over, so I get x cubed plus 2x squared minus x minus 2 equals 0. And then I could just graph this and see where it equals 0, because if I think of this right here, the y2 as being 0, well, y equals 0 is just the x-axis. So if I graph this, I can just see where it crosses the x-axis, and hopefully it'll be those exact same values at -2 and -1 and 1. So let's see what that looks like. Let me go to my calculator here, and I'm going to subtract x and subtract 2 from both sides. And when I subtract x and subtract 2 here, that's just going to give me 0. And I'll just go ahead and clear that out because it'll just be the x-axis when I graph it. So let me hit the graph button. Let me take a brief screenshot of that. Okay, and so now we can see that here x equals -2 and x equals -1 and x equals 1. Those are all the same solutions that we got over here using the intersection method. Okay? Now if I want to solve it algebraically, I do exactly what I started to do with the zero method. I need to get 0 on one side, and then I'll go ahead and group these together. Notice I can factor out an x squared from these first two. I can factor a negative out of the second two. And then I can go ahead and factor the x plus 2 out. There's a common factor of x plus 2 here and here. When I do that, I'll be left with x squared here minus 1 right here, right? X squared times x plus 2 is right here, and x plus 2 times minus 1 is right here. And then notice I can factor this a little further. That's the difference of squares. That's x plus 1, x minus 1. And then using the principle of zero products, if I multiply three numbers together to get 0, one of them must be 0. So either the x plus 2 is 0, or the x plus 1 is 0, or the x minus 1 is 0. And that's going to give me my same solutions, right? If I solve this, I get x equals -2. This will give me x equals -1, and this will give me x equals +1. Okay, so that's how we would solve a polynomial equation, either using the intersection method or the zero method, doing it graphically, or that same problem algebraically. Here's another problem that asks us to find the zeros of this particular function. Remember, the zeros are the x values that make it equal to 0. So I want to find where the output, where the y value is 0. When I graph that, that's going to be along the x-axis. So if I want to find it graphically, I'm looking for the x-intercepts. So let's go ahead and graph this. Let me go back to my y equals, and I'll put in here x to the third minus 2x squared minus 3x. And if I graph that, I'm going to hit my standard window again. And it looks like there's going to be x-intercepts going to cross at x equals -1 and 0 and 1, 2, 3, it looks like there. Okay, maybe I'll zoom in on that a little bit. But let me take a screenshot of that. So again, if I'm looking for the zeros, I just need to graph that and find where the y value, the output, the function value is 0. That means that you're going to be along the x-axis here. And that gives me x equals -1. This one would give me x equals 0. And this one would give me x equals +3. Okay, now I can do that same thing algebraically by finding where the output, the y value, is 0, right? So if, let me actually write this out again here. Here's my function. And if I'm looking for the zeros, I want to know where that output y value is 0. Okay, so then I just have to solve this. I can do that by first factoring out an x. And then I can factor this remaining trinomial by breaking it into two binomials. And I know I multiply x by x to get x squared. I'm going to have to multiply 3 times 1 to get 3. And one of them is going to have to be a negative, one's going to be a positive. Now, when I do the outers and inners, I want to end up with a -2x. So I'm going to put the negative on the 3, the bigger factor, and positive on the 1. Then double check x times x is x squared. 1x minus 3x from the outers and inners does give you -2x, and then the -3 times 1 is -3. So I have 3 numbers multiplied together to give me 0. Either this first number is 0, or the x minus 3 is 0. And if I set that equal to 0, that's going to make x equal 3. Or the x plus 1 is going to equal 0. And if I set that equal to 0, x will be -1. And you'll notice that those are the very same values that we got over here when we did it graphically, which is what we'd expect. Okay? One last problem that I want to go over here is to think about solving this equation. The problem asks us to use an appropriate viewing window on our calculator to solve this, and then use that viewing window as an aid to solve it algebraically. So what I'd want to do is I want to think of this as 2x squared minus 51x plus 25 equals 0. And I'm going to go ahead and graph this. I'm going to let this be my y equals on my calculator here. So if I graph 2x squared minus 51x plus 25, and I'm going to hit my standard window here and see what I get. Looks like there's going to be one x-intercept fairly close here, and it looks like this is a parabola going down. It's probably going to come up over here. Let me zoom out a little bit right here and see if we can get that. Okay, yeah, there's the other part of it right there. So let me just change my window here to go from, like, say 0 in the x direction out to about, well, let's see how big that was. I think that was about, I'll zoom over, about 25, isn't it? So let me just get a little better window. Let me go from, like, say 0 to 30 here, and I'll show you an interesting trick. Once you have set your x's here, there's a special zoom feature, zoom fit, that's number 0 in the zoom options, and that will look at your x values and automatically create a corresponding y range here so you can see the whole parabola in it. Now what I really want to look at is these here, and it did ask me for my window range here, so looks like it went from about 0 to 30 in my x direction and about negative 300 to 300 in my y direction. Okay. So that'd be my window, and I'd like to know these points right here where it actually crosses the x-axis. So let me calculate the zeros there, and when I do that, it asks me for a left bound. So that means get on the left hand side of this 0, and that's in terms of the x. So I'm going to hit enter right there. And then it says go on the right hand side, give it a right bound, hit enter, and then give it a guess. So just get down there kind of close, and it says the 0 is in fact 25. Okay, and so I know that that one of my answers is going to be x equals 25, and then I could do the same thing over here. All right, but I'm going to show you something. I believe one of the answers is 25. And so I also know that there's a way to solve this algebraically by factoring. And I know if I'm going to factor, I'm going to get 2x and x. And notice that if one of the answers, if I know that's 25, if I bring the 25 over on this side, I get x minus 25 equals 0. And that gives me a clue that one of these factors is x minus 25. And once I have that, that makes it very easy to factor. So I'd multiply 2x times negative 25. Notice that's a negative 50x. What I need right here, and actually what I need to multiply the negative 25 by to get a positive 25, is a negative 1. So notice that that would give me 2x squared minus 50x minus x is the minus 51x in the middle, and there's 25. And then I could solve this algebraically. I would get 2x minus 1 equals 0, or x minus 25 equals 0. So this would be 2x equals 1, and x equals a half. And this would give me x equals 25. Now x equals 25, that's what we found by the graph. And if I go back to my graph, you'll notice I'll bet that a half is probably where it crosses the x-axis right there as well. Let me just calculate the value, and I'll just plug in 0.5, and sure enough you'll see that the y value is 0 at that point. Okay, so we sort of used a combination of methods there. I could have used the zero function here to find a half, and that would have given to me both. But we actually, I found it a little easier to use the factorization to find the half. And that's just an example of how you can use both your calculator and the algebra to work perhaps from different sides to get the same answer. Okay?